In the Lake Washington School District, STEM is a culture. It's part of our DNA. It's been a long-term dream of the district to be able to have a STEM program in each of the comprehensive high schools, and that permeates into the middle schools and elementary schools.
Lake Washington School District is still on a tremendous growth pattern. There's a very real need to have more classroom space for their growing student body. Coupled with this intense desire to roll out a STEM program, they needed seats.
In 2010, the voters approved the levy that would build this STEM program. Before that, though, we did not have the money to be able to go and design the school. In parallel, we were moving from a 3-year high school to a 4-year high school.
The goal was to have the capacity increase for moving 9th graders up to the high school level implemented for the fall of 2012.
That made the schedule extremely short.
We immediately landed on modular construction as our alternative delivery method so that we can do design concurrent with permit to make this schedule.
When we were first starting on the job, the school district knew this building was going to be a modular construction building, and they said it needs to be of the same quality and the same curriculum standards as our other schools that we site build. In other words, this can't look like a bunch of portables, and that alone was a challenge. How do we take a construction methodology that typically is associated with temporary classrooms and turn it into something that can be a 50-year plus institution that can serve the unique needs of 21st century learning?
Integris developed a set of documents to bid from. They fully designed, engineered the architectural features, the structural features, etc. And since the structure itself is modular, a lot of the work is actually done at a manufacturing plant. What that does is creates a lot more pre-planning for the project while that construction is going on off-site. Between M-Space and Blazer, the modular manufacturer and contractor, Absher, Lake Washington School District, and Integris, we had to work through all those details to make sure that the quality standards as well as the design elements were being incorporated into the modular construction.
We are so used to doing stick-built projects, so being able to have that collaboration was so pivotal with the STEM project. We went through an engineering phase with Blazer. They took our construction documents and re-engineered the drawings so it was suitable for modular construction, but also as an opportunity for them to recommend different ways of addressing like a floor assembly system, etc., based off of their experiences.
One of the things that we have been trying to endeavor to do is to make sure that our projects are flexible, adaptable, and convertible. We really want the programs to be the driver of the environment or the spaces.
So consequently, a traditional classroom setting is not conducive to a STEM program. There's a need to have the building be more fluid in terms of lab spaces, more square footage into group and lab activities, and so as a result the design is uniquely different than a standard high school program.
STEM is modeled into 8 academic clusters, and each cluster has 2 learning settings and 1 studio. The science studios are collaborative spaces. We have learning settings that are adjacent to it, but there's an operable wall. So there's the opportunity to have the 2 classes merge. The heart of STEM is Presentation Hall, which is a public space, and it's a double height space where students present their projects to working professionals and also their colleagues and teachers. The other double height spaces are the commons areas.
We've noticed that the kids use every space here as a learning space. There is not 1 square foot in this building that isn't being used for teaching and learning and instruction. They like the flexible space, that they are not in one room or one area and it can only be worked one way. They like being able to get up, move, get with either a partner or small group or half the class, if you will, and keep working.
Students learn differently. Not everybody learns by just reading a book. Not everyone learns by hearing a lecturer. And we wanted to have a school that allowed for spaces that gave opportunities for students that really helped them become career ready.
I think what we're learning in this process is that modularly constructed, significant school building is an absolutely valid delivery model for a high quality 50+ year learning environment that a lot of school districts are looking for.
We believe in the future where we've got these types of demands by school districts, that this modular approach that we use for the STEM program has application to other kinds of schools. Based upon the collaboration we had among the module manufacturer, the architect, the contractor, and the district, this project, I think, has developed a model by which we don't have to be constrained by the traditional way of doing business, and at the end of the day say, how do we solve this problem? How do we serve those students and those families and the community?